Hello students, today's my topic is basics of probability and I am going to explain experiments and sample pace. Now we all are very well known with the term experiment. We performed the experiments in physics, chemistry, biology. In statistics, it is not necessarily restricted to laboratories experiments. Experiment is virtually operation that results in one or more outcomes. We can predict all possible outcomes of experiments without conducting the experiment on the basis of logical reasoning. For example, tossing a coin is an experiment with two possible outcomes. Head will turn up or tail will turn up. Head or tail. The second example is throwing a six-faced die with possible outcomes are 1, 2, 3, 4, 5, 6. The next example is releasing a stone from hand with possible outcome is that it will fall on the ground. The another example of experiment is appearing for F.Y.B.Sc examination is an experiment with possible outcomes as pass or fails. These are some examples of experiments. Now we see the next term is trial of an experiment. Trial of an experiment. Trial of an experiment is nothing but the performing experiment once. So, n trials of an experiment means performing the experiments n times, either sequentially or simultaneously. Now, there are two different types of experiments. The first type of experiment is deterministic experiment. Deterministic type experiments. Now, deterministic type experiments means in this type of experiments has unique outcome, hence it is certain. The outcome of this type of experiment can be predicted in advance before conducting the experiments. In other words, the deterministic type experiments are predictable phenomena. For example, throwing a ball in the sky, then outcome of this experiment is the ball will fall on the ground. The second example is cooling water below 0 degrees Celsius. Outcome is freeze or ice. These are the examples of the deterministic type experiments. The second type of experiment is non-deterministic. Second type is non-deterministic type experiments. non-deterministic type experiments. This type of experiments has more than one possible outcomes. Its all possible outcomes can be predicted in advance before conducting the experiment. However, its certain outcome cannot be predicted before conducting the experiments. For example, throwing a 6-faced die with possible outcomes are 1, 2, 3, 4, 5, 6. Second example is tossing a coin with possible outcomes are head will turn up or tail will turn up. Now, we are interested only in non-deterministic type of experiments, or it is also called as the random experiments. Then now we see the concept of the types of experiments, deterministic type of experiments and non-deterministic type of experiments. After that, the concept is statistical regularity. Statistical regularity. Though we cannot predict the outcome of a single trial of the experiments, but we can get some knowledge about the outcomes among the experiments when the experiment is performed repeatedly a large number of times. For example, we cannot say whether head will turn up or tail will turn up if a fair coin is tossed. However, if the coin is tossed 1000 times, if coin is tossed 1000 times, in this case, what will we expect? This is the question. In this case, we expect that about 500 times head will turn up and about 500 times tail will turn up. If we further increasing the number of tossings, in that case we expect that the proportion of getting head should approach to the value 1/2. Thus, the proportion of getting head approach to value 1/2 as number of tossing increases. Thus, though we cannot predict the outcome of any particular experiment, in this case there exists a long-term regularity, and this is basis for the development of the random experiments. Also, it is called as the probabilistic models or non-deterministic type experiments. Okay. Now we see the concept of sample space. Sample space. Sample space. The definition of sample space is a set of all possible outcomes of any random experiment is called as sample space. For example, consider the experiment of tossing 2 coins simultaneously. Then for this experiment, sample space is omega is equal to HH, HT, TH and TT. The sample space is denoted by omega. The second example is tossing a coin until head appears. Then for this experiment, sample space is omega is equal to H, TH, TT, H, T, 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 H, so on. This is the second example of sample space. Now, third example of sample space is measuring height of a person. In this case, if we know the minimum height and maximum height, in that case we can write sample space as 130, 190. That is 130 is the minimum height, 190 is the maximum height, or 130 is the lowest height and 190 is the highest height. And for this experiment, sample space omega is equal to 130 to 190. In this interval, there are uncountably infinite number of sample points or sample elements. The first example contains the finite number of outcomes. In second example, contains countably infinite number of outcomes, and in third example there are uncountably infinite number of outcomes. This is the concept of sample space. Now we see types of sample space. First type is discrete sample space. Discrete sample space. Discrete sample space means if sample space contains finite number of elements or countably infinite number of elements, then the sample space is called as the discrete sample space. For example, consider the experiment of throwing a 6-faced die. Then the sample space will be omega is equal to 1, 2, 3, 4, 5, 6. In this sample space, there are finite number of elements. Therefore, this sample space is called as the finite sample space. The second example is tossing a coin until head appears. Then sample space is what? Omega is equal to H, TH, TTH, TTTH and so on. In this sample space, there are countably infinite number of elements. This is the second example of the discrete sample space. In discrete sample space, there are finite number of elements or countably infinite number of elements. And these two examples belongs to first one is finite sample space and second one is countably infinite sample space. Then second type of sample space is continuous sample space. Second type is continuous sample space. If sample space contains uncountably infinite number of elements, then the sample space is called as the continuous sample space. For example, suppose we have to measure the weight of a person, and if we know the lowest weight and highest weight, in that case the sample space can be written as omega is equal to, suppose lowest weight is 40 kg and highest weight is 150 kg. We have this interval. In this interval there are uncountably infinite number of elements. Therefore, this is the continuous sample space.